So if you look at the notes, partitioning a segment is what we're doing today. So basically, where we split a segment yesterday by a midpoint, cutting it in two equal sections, that it could be a little bit different. It could be split to where we want a point that splits the segment into a section where the longer one is twice as long as the shorter one. Or, something else. Maybe it's 3 times longer than the shorter one, etc. So that is called partitioning a line segment. So basically you're cutting it into some other type of split. Alright, so I think this point's supposed to be at 0, 0. It's probably just hard to put points on documents for whoever made this, but it's still nice to have. So, and that one's supposed to be on 6. So basically, if you think about a midpoint, and let's say we're trying to find the midpoint between 0 and 6 just on a single number line, well, what number's directly in between 0 and 6? Well, if we look, 1, 2, 3 away would be this number, 3, and 1, 2, 3 away would be number 3. So the actual midpoint would be right at 3. That's an even split where each length is the same. Or so the distance from 3 to 0 is the same as the distance from 3 to 1. So that's like a 1-to-1 ratio, where they're the same length. So let's say, for instance, we have the points at 0, just move that point over a little bit, and 9. So if we wanted, sorry, it's kind of crazy looking, but if we wanted a 2-to-1 ratio, that means we want one segment to be 2 times longer than the other. So one way to do that, if you look at it, we will then need 3 equal parts, because in order to do that, we need to split. So from 0 to 9, if we're going to do it into 3 equal parts, well, 9 divided by 3 is 3, so every 1, 2, 3 will have a section. 1, 2, 3 will have a section, and then 1, 2, 3. So they're all even parts, but we want a point where one of them's 2 times longer than the other one. One segment's 2 times longer than the other. So you just basically just go 2 sections, 1, 2, and that will be your point. So now you see that this segment on this side is 2 times longer than this segment over here, because this segment, I'll just make in blue, this segment is now 6 units long, and this segment is 3 units long, if that really goes to 9 like it's supposed to. I wrote 9, but I meant 3 units long. So therefore, it satisfies the ratio 2-to-1, where we have one segment 2 times longer than the other. So first, in order to understand how to do this, you first got to understand how many equal parts you should have. Because notice, I wanted a 2-to-1 ratio right here, but I had to have 3 equal parts to make that happen. So in order to figure out how many sections you need, all you do is you add the 2 numbers together. So I do 2 plus 1, that's 3 equal parts. So in this section right here, it's just asking you to determine how many equal parts you would need. We'll just add the 2 numbers together, and that's how many equal parts you would need. So in this case, you would need 7 equal parts. So for B, go ahead and write how many you need. Hit pause if you want, but yeah, you should definitely have 8 equal parts. So all you're doing is you're adding those 2 numbers to determine how many equal parts you need to split the line into. So if you add 1 and 2, hopefully you can think ahead of me. Yeah, you should have 3 equal parts. And then for 3 and 8, you add those together, you should have 11 equal parts. So that's how many equal parts you need in order to split the line into that ratio. So if we just do this on a single number line, basically it tells us to put point P at 1. So if I put point P at 1, this is our point P, and Q at 7, so put Q at 7. We want to find the point T so that T partitions P and Q into 2-to-1 ratio. So right there, I should look and say, okay, I need 3 equal parts. So for that one, you should have got T is at 4. All right, so go ahead and try number 3, and I'm going to pause it. Remember to look to see how many sections you need to split it in. So for that one, you should have got S is at 3. So I'll do the next one as you play it. So if you want to, you can skip through it just straight to the answer. But just in case you're not kind of understanding it, I'm just going to work through this one. So we have t is at -8. We have r is at 6. So let me put t, let me put r. And we want to find c so that it's 3/7 of tr. So since it didn't give us an actual ratio there, what it is doing is it's telling us it wants the point C so that it's 3 sections out of 7. So 3/7 of TR means that it wants it to be 3 sections out of 7 out of 7 sections if we split TR. So let's first figure out how many or where our sections will need to be. So I'm at 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have 14 units, but I need to put my point so that it's 3 of the 7 sections. So we're going to divide this by 7 to know where we should put our section lines. So we're going to put our section lines at every 2 units. So at every 2 units, I'm going to make section lines. And really, if you know you're going to make it at 3 of those 7 sections, we just made the 3. So technically, you can go ahead and plot it after you find your third section. 1, 2, 3, that's our third section line. So right there, our C should be at -2. All right, so that's if you don't have a ratio to work with there. Anytime you're given a ratio, you do need to add the 2 numbers together to figure out how many sections. But if they give you a fraction, they're telling you how many sections you need to split your segment in. All right, so of course we need to do this in the coordinate plane because that's the unit we're in. We're doing everything in the coordinate plane. So this is how you're going to do it if you have 2 dimensions, not just an x-axis. Well, if we have an x and y-axis. First, just as before, we need to plot the coordinates. So if you look at the coordinates they give us, they say that a is -2, 4. So -2, +4, there's our a. And b is 7, -2. So there's our b. So you may need to hit pause as you plot. So our segment looks like that. So we basically need to find the point C so that it partitions line AB into a ratio of 1 to 2. So right there, you should see that we're going to need 3 equal parts. And if you look into this formula, that looks a little nuts right now, but all you're doing there is your A plus your B is what you did. You just found that you need 3 equal parts. And the A and B come from just the ratio here. So A is 1, B is 2. So anywhere you see an A in this formula, you're going to put A1, and anywhere you see a B in the formula, you're going to put a 2. And x2 and x1, those are just from your coordinates, just like they've always been. So I'm going to go ahead and label. Same thing with y2 and y1. So this is our x1, so that's our first coordinate, and our y1, because that's our y of our first coordinate. And then this is our x2, since it's from our second coordinate, and this is our y2, because it's from our second coordinate. So now, really, we just substitute in the values we have. We already know our a plus our b is equal to 3. So it looks crazy, but it really just gives you the point after you do the math. So I'm just going to go ahead and show that down here. So it just has a parenthesis there because that is just for the coordinate. But we have to do x2 minus x1. So x2 in this case is 7. So we have to do 7 minus x1, which is -2. So we're doing 7 minus a -2. Make sure you don't think that minus is your negative. And then we're multiplying it by a over the a plus b, which we know a plus b is 3. And then we have to add back to it x1. So x1 we know is -2. All right, so I know it looks like a lot, but really you could put all that in the calculator, so it's really not that much. Or you could do it in parts. So you'll see what that equals. That'll be the x value of the point where we need to partition this thing. And then comma. So now we'll do the y's. So y2, which is 2, minus, I'm just following the format of this, minus y1, which is 4. And then we're multiplying by the fraction a, once again, which is 1, over a plus b, which we know is 3, and then plus our y1. So our y1 is 4. So if we do all that right here, we should get the y value of the point that we need. So let's go ahead and do that math and see what we get. Oh, I just realized something, which you guys may have noticed it. Underneath, my y2 right here is a negative. So make sure you include the negative for y2, which should go right there. So now negative 2 minus 4. So when you do that math, if you notice here I already did the x value is 1. When you do that math, you get 2. So your coordinate for the point, I don't know why I have 2 commas in there. Let me erase this one. Your coordinate for the point should be, bring this over, all right, 1, 2. So it may seem like a lot, but really if you're good at just plugging stuff in the right place, you'll be fine. Now, of course, some of you guys might be like, oh my gosh, it's so much. What's the easier way? Now, visually, there is a way to do this, so I'm going to show you that too, just kind of how I showed you yesterday with the midpoint. With the endpoint, with finding an endpoint, you could do that using the formula, or you could do it kind of like with the number sense way. So if you wanted to do it a little bit quicker, but still you kind of got to make sure you pay attention to detail, what you would do here is you would look at your ratio, and you would make a fraction out of the a over the equal parts. So it's going to be a over a plus b. So you find that fraction first. Well, we know a is 1, and then if you just add the two numbers together, that's 3. So you're going to need that. So hang on to that for a minute. And then you just find your slope, your rise and your run for the line. But remember, when you find slope, make sure you're really careful. So if I find my m, my rise and my run, I notice I'm rising 1, 2, 3, 4, 5, 6, 7. Nope, went too many. 1, 2, 3, 4, 5, 6. So I'm rising 6, and I'm going over towards the negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went over towards the negatives 9. Remember, slope is rise on top, so 6 over run, which is negative 9. So now that you have your slope, you can simplify if you want, but you don't necessarily have to, because that's not your key point of finding it. Now you're just going to multiply both numbers of your slope. So you're going to multiply your 6 times, so let me make this fraction a little bit taller, 6 over negative 9. We're going to multiply the top by 1/3, which is our fraction that we got earlier, and your bottom by 1/3. And so when you do that, if you use a calculator or your brain, whichever one you like, you get 2 over negative 3. Well, what does that do for us? That tells us the slope we need to use to get to the coordinate that we're looking for. So basically, your number here, if we're going, you have to do it from the starting point though. Notice we start with point A. So you have to do it from that point. So basically from that point, we can't rise 2. So remember, when you're dealing with slope, you can go the opposite direction, because a 2 divided by a negative 3 is the same thing as a negative 2 divided by a positive 3, because if the fraction is negative, it's negative no matter what. So if you can't go up, just put the negative in the numerator instead. So we're going down 2 and over positive 3. 1, 2, 3. And you should recognize that point right there is 1, 2, which is the same thing we got when we used the formula. So either way is perfectly fine. So let me just recap what we did in that short way. We found the fraction a over a plus b, and then we just found our slope, and then we multiplied our slope by that fraction, which gave us a new slope, basically. And that slope tells us how to get to the point that we're looking for. And that's our point. So it's either that route or the formula route. Doesn't matter which one you use, but I'll show both again on example 2. So just to show the visual route first, because it could tend to be a little faster, remember what we do is we go ahead and plot the points. Obviously, that'd be step 1. So -2, 1, 2, is A. B is 7, 6. So over 7, -6, down to -6. And that is our point B, if you go ahead and connect them. All right, and so now we need to find the coordinate P, so that it has a ratio of 1 to 3. So if I add them, I know that's 4 equal parts. My A is 1, so my fraction is 1/4. Now if I do my rise and run on the actual graph to find my slope, 1, 2, 3, 4, 5, 6, 7, 8. So that's up 8 towards the negatives, 1, 2, 3, 4, 5, 6, 7, 8. So towards the negatives 8. So my slope is rise first over run. So it's just a -8/8. We could simplify this if you wanted to, but if you simplify it, make sure you leave it as a fraction so you kind of know your ratio. So if we leave it as is, and we just multiply by the 1/4, because remember, you don't have to simplify it. Multiply it by that fraction on the top and bottom. That becomes -2/2. Oh, you know what, correction, do not simplify this. If you simplify it, it won't keep it into the equal, into the unit. So leave it as is, multiply by the fraction, simplifies to -2/2. So now we know the rise and run we need to do from our starting point to get to our partition point. So basically, we just need to go down 2 and over 2. So starting at point A, do it in purple, we're going to go down 2, 1, 2, and over +2, 1, 2. So this is our partition point, which looks like it's at 1, 0. All right, so just to do it at the formula so you understand it's not like crazy rocket science. I'm going to first write down the formula. Yes, I know it's a little lengthy, but it's not really difficult to use. So we have to do our x2 minus x1, which if you notice, this is just part of our slope formula, over the fraction. Now, we already know how to find this fraction right here. So I'm just going to put times that fraction. We know the fraction's 1/4. All right, and if you look at the formula, let me just go ahead and put the whole formula. It's just a over a plus b. That is that fraction where we just put the a over the sum of the ratio numbers. All right, so that's the first part. And then the y part is just like it. So I'm going to do that separately, y2, just because I don't have room, minus y1 over the same fraction. So everything's the same at the end. It's just using y's instead of x's. So really, it's just kind of like the same thing, just x's and y's. All right, so now I'm going to go ahead and substitute. So if I label my coordinates x1 and y1, so I don't have a lot of room up here, so I may have to erase a little bit. So x1, y1, x2, y2. So now I know my x1 is -1, my x2 is 7. So I should have 7 minus a -1, and then times the fraction I found earlier, which is just our first value of our ratio. Our ratio, remember, was 1 to 3. So our fraction is 1 over 4, because there's 4 equal parts, plus my x1, which my x1 is -1. So if I do that, my math should turn out to be 1. And then y2 minus y1, so my y2 is -6, minus my y1, which is 2. And then I multiply by that same fraction, and then I add back to it the y1, which y1 is 2. So if I do that math, I should get 0. So notice there, my coordinate is the same thing, 1, 0, that I get if I do it that way. All right, So go ahead and try example 3, and I'll go ahead and just go ahead and pause it, whichever way you want to do it, just pause it, and then we'll hit play and it'll reveal the answer. Alright, so for example 3, you should have got 5, 4. If you didn't get 5, 4, maybe go back and check your work. And then now if you got it right, go ahead and try example 4, hit pause now, and then I'll reveal the answer. So the answer for number 4 should be 3, -1. Alright, so that should be our answer for number 4, example 4. Alright, so your assignment after these notes is to do the back of the paper from yesterday. So the front says midpoint on it, the back says partitioning line segment. So go ahead and do the back side of that midpoint paper from yesterday. So that's your assignment. So do that, knock it out. It's only one-sided now that you should have done the midpoint on the front. So that should be completely doable. So the formulas are at the top of that too for the X and the Y if you, if you need it so you don't have to keep flipping to your notes. All right, do your work. Adios.